Alright, as promised, now on to the Bohr atom. I know that sounds like a really weird thing to say, the Bohr atom, but this is what you think of when you think of an atom. You think of the little nugget in the middle of all of your mass, all of your protons and neutrons, that chunk there in the middle, and then the electrons buzzing around the outside like the planets on their orbits around the sun. And it was developed by a gentleman by the name of Niels Bohr. And all it does is serve as an organization of the electrons. Later on, we will go into more in depth a little bit about where these electrons are when we get into Schrodinger's model and configs. But for now, we're just going to organize them into rings. So as I said, protons, electrons, and protons and neutrons go here in the middle. And then we can have as many rings as we need to provide homes for all of our electrons. But they follow a pattern. This first and innermost ring can only hold 2 electrons and no more. The second ring can only hold 8, the third row 18, the fourth row 32, the fifth ring 32, the sixth ring 32, and so on. You get the drift. So each of these rings can hold no more than this number of electrons, but they can hold less. So we're going to keep placing electrons until we run out of electrons, until they all have a home. We're always going to start So we will always start with that innermost ring and work our way out. We will also always fill a ring before moving on. 2 things you need to know. So let's try one. First, let's try beryllium. In order to draw my Bohr model of my beryllium atom, I need to do our protons, electrons, and neutrons just like we did in the last video. So I can put everybody where they go. If we look at the periodic table, here's beryllium right here. So we've got a 4 up here at the top, 9 down here at the bottom. That 4 up top tells me my number of protons. Since it says Bohr atom, that means protons and electrons are the same, so we have 4 electrons. Since my mass number is 9, 9 minus 4 tells me that I have 5 neutrons. So let's draw our picture. In the middle, we need to have our protons and our neutrons. So 4 protons, 5 neutrons. Now we start our rings. On the first ring, I can have no more than 2 electrons. So of this 4 electrons, I will place 2 on that ring. I need to get up to 4. I have placed 2, so I gotta keep going. My next ring can hold 8, but it doesn't have to. I don't have 8 more electrons. I only have 2 left. So those 2 electrons will go on that second ring. And there you have it, the Bohr model for a beryllium atom. 4 protons, 5 neutrons in the nucleus in the middle, 2 electrons on the first ring, and 2 electrons on the second ring. You'll remember that I told you these outermost electrons have a special name. They are called the valence electrons, and they determine the properties of our element, how well they bond, how combustible they are, etc., etc. Let's look at another example. The vanadium atom. Vanadium, there it is right there. So 23 is the atomic number, 51, if we round, is the mass number. Since my atomic number is 23, that means that I have 23 protons. Since it is a vanadium atom, protons equal electrons. So I have 23 electrons. All that remains is my neutrons. Mass number is 51. 51 minus 23 is what, 18? No, 28. 28. Look at that, I did it in my head. So here we go. Protons and neutrons in the middle. 23 protons, 28 neutrons. Let's start in on the rings. First ring can only hold 2 electrons. That ring is full. but I gotta keep going. I gotta get up to 23. Second ring can hold 8 electrons. So let's see, so far I've placed 10. I'm not done yet, gotta keep going. Third ring, if you remember, third ring can hold 18 electrons. If I've only got 10 left, or I've already placed 10, I gotta get to 23. That leaves me with only 13 electrons left. So I can't fill this outermost ring. I gotta stop at 13. So there you have it. 2 electrons on the first ring, 8 electrons on the third ring, 13 electrons on the outermost ring. But let me point out something a little strange. While the Bohr model is very useful and can tell us a lot of good information about an atom, it's not the best one. You might be tempted to say that this atom has 13 valence electrons, but I'll let you in on a secret. With valence electrons, you can have no more than 8. So there's something wrong here. Something's incorrect about this picture, but we don't know what it is yet. We'll figure that out at a later date. For now, suffice it with drawing the picture and saying that on the outermost ring, according to this picture, there are 13 electrons. That's just fine for this stage of the game. Let's look at an ion real quick. Sodium ion, we need to know protons, electrons, and neutrons in order to figure that out. So sodium, here he is. 11 is the atomic number, 22.99 is the mass number. And remember that ion or not, protons cannot change. My atomic number must remain the same anytime I'm talking about a particular atom. Since this is an ion, my protons and electrons will not match. Since it is a positive ion, I know that I need more positive and less negative, but remember, can't change that positive. So I'm stuck with 11 protons, so that means I gotta have less electrons. How many less? 1 less. He will have 10 electrons. Neutrons, let's see, 23 mass number minus 11 protons gives us a neutron number of 12. Here we go with the diagram. 11 protons, 12 neutrons, onwards with the ring. First ring can only hold 2 electrons, no more. We're going to 10. Second ring can hold 8 electrons, and 2 plus 8 is 10. If you want to think about it another way, sodium atom would have 1 more electron to make it 11. So all you would do is draw your regular diagram for your sodium atom with his 1 electron on this next ring, and then take it off. For a sodium ion is a sodium atom that lost an electron. One more, let's do an isotope. So, ion changes electrons, isotope changes neutrons, remember. So this will be the only number that's different from a regular bromine atom. So here we go. Bromine has an atomic number of 35. We cannot change that. Since this is an isotope, that means that protons equal electrons. So 35 of those little guys. This is your mass number. So in order to find neutrons, mass number minus proton number is always going to give you that number of neutrons. The only difference in this situation is the fact that they gave you a specific mass number instead of you having to take it off of the periodic table. So this particular species of bromine, if you will, 46, I can't subtract, has 46 protons. That is different than a regular bromine, but that's okay. We can have special cases. Here we go with the diagram. In the nucleus, 35 protons, 46 neutrons, and now to place the electrons. 2 on the first ring. I'm going to 35. 8 on the second ring. That gives me a total of 10. Still going. Next ring can hold 18. If you remember, going back to our little diagram up front, 18 electrons on the third ring. 18 and 10 is not 35. So let's see, now we're up to 28. So let's see, 35 minus 28. All right, so we're going to finish up on that fourth ring. Fourth ring can hold a grand total of 32, but I don't have 32 electrons left to place. I only got 6. And there we have it. Did I add that right? No, you doofus. This is 7. Forgive me. I cannot brain, I has the dumb. That looks much better. So, if we were to say, how many valence electrons does this particular atom have? We would say 7. So I hope that clears up any confusion, concerns, worries you had about the Bohr model of the atom. It is very useful. And then later on, we will be talking about how to be a little bit more specific with this diagram so that we don't have problems like this, where I end up with way more valence electrons than are possible. And that's where Schrodinger and configurations come in. So if you're ready for that, check out those videos. Otherwise, best of luck. Always feel free to post questions and or comments down at the bottom. If these aren't helping you learn, they are not serving their purpose. So let me know how I can improve these. But otherwise, happy diagramming and see you next time.